I'll huff and I'll puff and I'll infect every piece of code on the planet while it gets compiled? And there's nothing you could do about it. What's up, everyone, and welcome. In this episode, we are going to talk about an underlying issue in software compilers that exists in almost every language and can be used for some really nasty stuff. Now, I know some of you may be saying, yeah, we know, this has been around for over a decade. And you're right, but it's getting some new attention, and since compilers are a foundational functional tool that we all use to build software, it has devastating potential.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
Virtually all compilers, programs that transform human-readable source code into computer-executable machine code, are vulnerable to an insidious attack in which an adversary can introduce targeted vulnerabilities into any software without being detected. New research released today warns. The vulnerability disclosure was coordinated with multiple organizations, some of whom are now releasing updates to address the security weakness. Researchers with the University of Cambridge discovered a bug that affects most computer code compilers and many software development environments. At issue is a component of the digital text encoding standard Unicode, which allows computers to exchange information regardless of the language used. Unicode currently defines more than 143,000 characters across 154 different language scripts, in addition to many non-script character sets, such as emojis. Specifically, the weakness involves Unicode's bidirectional, or BIDI, algorithm, which handles displaying text that includes mixed scripts with different display orders, such as Arabic, which is read from right to left, and English, left to right. But computer systems need to have a deterministic way of resolving conflicting directionality in text. Enter the BIDI override, which can be used to make left to right text read right to left, and vice versa.
Oops! Had the silly thing in reverse.
In some scenarios, the default ordering set by the BIDI algorithm may not be sufficient, the Cambridge researchers wrote. For these cases, BIDI override control characters enable switching the display ordering of groups of characters. BIDI overrides enable even single script characters to be displayed in an order different from their logical encoding. As the researchers point out, this fact has previously been exploited to disguise the file extensions of malware disseminated via email. Here's the problem. Most programming languages let you put these BIDI overrides in comments and strings. This is bad because most programming languages allow comments within which all text, including control characters, is ignored by compilers and interpreters. Also, it's bad because most programming languages allow string literals that may contain arbitrary characters, including control characters. So you can use them in source code that appears innocuous to human review that can actually do something nasty, said Ross Anderson, a professor of computer science at Cambridge and co-author of the research. That's bad news for projects like Linux and WebKit that accept contributions from random people, subject them to manual review, then incorporate them into critical code. This vulnerability is, as far as I know, the first one to affect almost everything, said Anderson. The research paper, which dubbed the vulnerability Trojan source, notes that while both comments and strings will have syntax-specific semantics indicating their start and end, these bounds are not respected by BIDI overrides. Therefore, by placing BIDI override characters exclusively within comments and strings, we can smuggle them into source code in a manner that most compilers will accept. Our key insight is that we can reorder source code characters in such a way that resulting display order also represents syntactically valid source code. Bringing all this together, we arrive at a novel supply chain attack on source code. By injecting Unicode BIDI override characters into comments and strings, an adversary can produce syntactically valid source code in most modern languages for which the display order of characters presents logic that diverges from the real logic. In effect, we anagram program A into program B. Anderson said such an attack could be challenging for human code reviewer to detect because we're mortals and we make mistakes, as the rendered source code looks perfectly acceptable. If the change in logic is subtle enough to go undetected in subsequent testing, an adversary could introduce targeted vulnerabilities without being detected. Equally concerning is that BIDI override characters persist through the copy and paste functions on most modern browsers, editors, and operating systems. Any developer who copies code from an untrusted source into a protected codebase may inadvertently introduce an invisible vulnerability, Anderson told Krebs on Security. Such code copying is a significant source of real-world security exploits. Matthew Green, an associate professor at the Johns Hopkins Information Security Institute, said the Cambridge research clearly shows that most compilers can be tricked with Unicode into processing code in a different way than a reader would expect it to be processed. Before reading this paper, the idea that Unicode could be exploited in some way wouldn't have surprised me, Green told Krebs on Security. He's from Johns Hopkins. I don't know if I'm giving it a British accent, but let's keep rolling. What does surprise me is how many compilers will happily pass Unicode without any defenses, and how effective their right-to-left encoding technique is at sneaking code into codebases. It's a really clever trick I didn't even know was possible. Yikes! Green said the good news is that the researchers conducted a widespread vulnerability scan but were unable to find evidence that anyone was exploited yet. The bad news is that there were no defenses to it, and now that people know about it, they might start exploiting it, Green said. Hopefully, compiler and code editor developers would patch this quickly, but since some people don't update their development tools regularly, there'll be some risk for a while at least. Nicholas Weaver, a lecturer at the Computer Science Department at University of California, Berkeley, said the Cambridge research presents a very simple, elegant set of attacks that could make supply chain attacks much, much worse. It is already hard for humans to tell us this is okay from this is evil in source code. With this attack, you can use the shift in directionality to change how things render with comments and strings so that, for example, this is okay is how it renders, but this is okay is how it exists in the code. This, fortunately, has a very easy signature to scan for, so compilers can detect it if they encounter it in the future. 11 other recipients had bug bounty programs offering payment for vulnerability disclosures, but of these, only 5 paid bounties with an average payment of $2,246 and a range of $4,475, the researchers reported. Anderson said so far about half the organizations maintain the affected computer programming languages contacted have promised patches. Others are dragging their feet. We'll monitor their deployment over the next few days, Anderson said. We also expect action from GitHub, GitLab, and Atlassian, so their tools should detect attacks on code in languages that still lack BIDI character filtering. As for what needs to be done about Trojan source, the researchers urge governments and firms that rely on critical software to identify their suppliers' posture, exert pressure on them to implement adequate defenses, and ensure that any gaps are covered by controls elsewhere in their toolchain. The fact that Trojan source vulnerability affects almost all computer languages makes it a rare opportunity for a system-wide and ecologically valid cross-platform and cross-vendor comparison of responses. The paper concludes, as powerful supply chain attacks can be launched easily using these techniques, it is essential for organizations that participate in a software supply chain to implement defenses. Now, Rust has released a security advisory for the security weaknesses, which is being tracked as CV 2021-42574 and CV 2021-42694. Additional security advisories from other affected languages will most likely be added as they are deployed. So, what can we learn? Well, if we stay in our own bubble and say, well, our code is safe, still doesn't mean that what you're compiling and selling or giving out to customers or users is also safe. We need to make sure that we exert pressure on the companies that produce these types of software or compilers, or in the sense of CMS systems like the WordPress episode I did the other day. We need to put pressure on the WordPress organization, on the Drupal organization, the Joomla organization, or any organization that is producing code, that they take more responsibility for pieces that come into their code, whether through the open source community, through a closed source community, through their internal developers, or any partners that have access and a say into what comes into these products. With that, I say thanks again for watching. Don't forget to share and subscribe if you haven't already, and smash that bell if you haven't already, and I will see you on the next episode. Take care.